Imine formation can be reversed by adding water, according to Le Chatelier's principle. If we increase the concentration of water on the left side, it's going to push the reaction to the right. This assessment asks us to draw the mechanism of the acid-catalyzed reaction in the reverse direction. Well, if we have water and sulfuric acid in solution, what we're really going to have is H3O+, so that's going to be the acid that starts this reaction. Now, looking at this, we might imagine a reaction where water as a nucleophile will add to the imine. Imines are not good electrophiles, and so we have to protonate it in order to get the imine to be electrophilic enough for water to attack. Now, if we protonate the imine, we end up with this iminium ion. This iminium ion is more electrophilic, for one, because it has a positive charge on nitrogen, but also it's electrophilic at carbon because we can draw this resonance structure, which shows that that positive charge is spread out onto carbon as well. With this carbon having a positive charge, we can now imagine water as a weak nucleophile being able to donate a pair of electrons to that empty p orbital. That's going to get us to a molecule that looks like this. Note that water has brought along its proton. And so in the next step, we need to remove that proton. And so we can use another molecule of water to do that. That's a step we have seen a number of times. If we're thinking about where we're trying to go with this reaction, and it's always a good idea when the answer is on the page, we need to get this group here containing the amine, we need to get it to leave. Well, it's not a very good leaving group on its own, but perhaps we can protonate it to make it a better leaving group. And we can do that using the H3O+ in solution. Now I worry that I'm going to start to run out of space here, and I'll apologize for that. Let me try to squeeze everything in. That gets us to here. We've now generated a molecule that has a positive charge on that nitrogen. We've made it into a better leaving group. As a better leaving group, it can leave. Now, that's going to give us this, and again, the space is getting even worse. Sorry about this, but we're so far into it. Let's just finish. That's going to give us this carbocation plus this amine. Now, if we wanted to, we could draw a resonance structure which shows that a pair of electrons on oxygen can be used to stabilize that positive charge, making it look like a protonated ketone. But what we also have is a base. And so we can simply show this amine base that we've just formed, grabbing that proton and allowing these electrons to collapse back down. Showing it either way would be equally correct, but because we're out of space, having this amine grab that proton would take us directly to this ketone as our product. So we've made our new carbon-oxygen double bond, and this ethylamine becomes our ethyl ammonium. That's the mechanism of hydrolysis of an imine using acid catalysis.